In order to be able to do part 2 of the lab, you need to go answer through the questions. Specifically, I'm going to go through 4, 5, and 6, which is how to fill out the table with all the samples that you're going to be testing in the lab. And in order to do this, you first need the balanced equation. Sorry. So it's CaCl2 plus Na2CO3, giving you CaCO3. That's calcium carbonate, that was your solid, plus 2NaCl. Okay, for question number 4, it asks you how many moles of calcium chloride are there in each of the samples that are in that table. So I'm going to show you the first one. It says 20 milliliters. So 20 milliliters, if you convert it to liters, is 0.02 liters. Okay, and the first sample is 0.4 molar. Molar, if you remember from Chem 1, is moles per liter. That's what molarity is, moles per liter. So we multiply those two together, it's going to give you the moles of calcium ion, which in this case is 0.008 moles. Okay. Now, in the data table it says theoretical amount of CaCO3 precipitate. That's the next column. So that would this answer, the 0.008, would be your first column, the moles of Ca2 plus in 20 milliliters of solution. The next one is the theoretical precipitate. So in order to do that, you take your 0.008 moles, so 0.008 moles, and you're going to multiply that by the mass of calcium carbonate, which is 100. Okay, this should be a pretty easy thing. So you got 1 mole on the bottom, you got 100 grams here. Multiply that out. That means 0.8 grams. Okay, and that's you're just going to follow that right down and do that for all of the things in the chart. The next thing says how much excess sodium carbonate do you need to add. So in order to do that, you need to take your 0.008 moles of calcium carbonate. Convert it to moles of Na2CO3. So if you look up in the equation up above, there's 1 mole here, there's 1 mole here. So 1 mole here, 1 mole of sodium carbonate up top. And we want to know volume, so what we're going to do is use the concentration that's given to us. The concentration that's given to us in problem 5 says it's 0.5 molar sodium carbonate. So what that means is 0.5 molar means for every, there are 0.5 moles in every 1 liter. So 0.5 moles per liter. Okay, that's what 0.5 molar means. So when you go through here and you do this, you're going to get the volume that you're supposed to get. Now, I'm going to save you time. Take whatever your answer is here, and just as the problem says, multiply it by 1.2 because we want an excess of sodium carbonate. So the 1.2 is going to make sure that we just solve for the amount that will react. 1.2 is going to give us 20% extra. So when you do that, you're going to get 0.019 liters, which is 19 milliliters. So I can write 19 milliliters into that chart, or if you want to just round up and call it 20, you can put 20 into the chart. So that should fill in the next column, which is volume of 0.5 molar Na2CO3 to add. The final column is the theoretical water hardness. If you just follow the example that is given to you right in problem number 6, you should be able to fill in that chart as you go down. So now that you have all that chart filled in, you need to design the procedure for how are you going to do the reaction. It's going to be just like what you did on the first day. So how are you going to do the reaction? Figure out how much precipitate you're going to get. You're going to compare it to the theoretical hardness that you have, that you just calculated in here.